I'm Jeff Zarnett, and this is Software Career Growth. Today, I'm going to be talking about learning a new programming language. Today's video is for individual contributors about learning a new programming language. It's a way that you can progress and you can grow and improve your skills in a way that's self-directed and at your own pace. So there are a few reasons why it would be beneficial to learn a new programming language, and some of them are to a certain extent obvious. Right. The obvious one that I can think of right off the top is, well, you can then add it to your CV, your resume. You can say, I now know this new language, and that is potentially beneficial. As much as that might be frustrating for those of us who work in engineering, that why does the job care whether I've got previous Ruby experience when I could learn Ruby? It's not that hard. When you already know 3 other programming languages extremely well, like what's one more? It still matters. Recruiters still look for it. Hiring managers still look for it, and not every company is willing to let you learn about the language on the go, on the job. So that might actually make a difference. It's not the strongest reason to learn a language, but it is there. Another reason why we might want to learn a language, and now we're into ones that I actually like, is that for every new tool, there are certain use cases that tool is very well suited to. Right? In this example, I'm going to talk a lot about Rust. I like Rust. There's no sense in denying it. In fact, if you look on my channel, there's some videos about Rust in the context of a course that I teach. So you shouldn't be surprised if I wow, I really like Rust. And in fact, it's even in the thumbnail for this video. So that part shouldn't be super surprising. But learning a new language gives you some new tool. When you can approach a problem, you can say, I know that Rust is really good at this. Right? Rust is very predictable in terms of runtimes because it doesn't have garbage collection, and so it's really good for something where, I care about responding to an event within a certain period of time. Similarly, Rust is also good for something like embedded system, where we're worried about concurrency problems or memory issues. Knowing Rust, we could actually make use of that tool. Now, getting your company to adopt it may not be that easy. In fact, realistically, you probably need 2 or 3 people who are knowledgeable about the language and strong enough advocates for it that they would be willing to invest time in helping other people learn it. But it's possible. It's doable. So that's a reason. Another reason, whenever you work with a new language, you will inevitably be exposed to new libraries, new ways of doing things. Every language has its own philosophy about tests, how tests should be written, what kind of tests, but also test libraries. Mocking functionality is different between languages. Recently, I was trying to do some mocking in Rust, and I learned about a library where I was faking HTTP responses, and that was a little bit different than what I was used to previously, where I would create a spy object in Kotlin and would accordingly be able to fake responses easily that way. But I learned something new, right? And I learned a new approach. And this approach allowed me to validate actually that the outgoing call contained the correct parameters, it was built correctly, and that we could parse the response in the library. It was a GitLab tool, so we were trying to operate on repos in GitLab, and so we could make sure that we were forming the query correctly and parsing the response correctly. So that was actually pretty nice. And learning this new thing was helpful, taught me something that I otherwise didn't know. But the biggest reason, and the one that I really think makes a difference, is that many languages force you to adopt a new way of thinking. And again, I'm going to talk about Rust in this sense. If you've tried writing some Rust, you may find it initially to be very frustrating. The Rust compiler is checking carefully to make a determination about whether there exists a possibility of a race condition. It says, well, you're borrowing this, and there's like an immutable borrow here, so you can't have a mutable borrow there. Or alternatively, you want to pass some data between threads, and Rust says, well, you can't send it to thread number 2 because it's already been sent to thread number 3. And you don't know what to do with that, and it feels very frustrating. As much as that can be annoying, the Rust compiler is trying to help you. It's trying to encourage you to think about the problem in a certain way. And when I teach students about C, I talk to them about memory allocation. So, okay, you allocate your memory with malloc, you have to deallocate it at some point with free, and I encourage you to think about how long this memory is going to live at the time that it is allocated, so you know what it's for. It is a buffer. We're going to use it to receive data over the network. Once the data has been in the buffer, we will then write it to a file. After we've written it to a file, we can deallocate this memory, right? You have to think about that lifetime. You have to choose carefully where to place the free statement. Rust forces you in a way to deal with that, and in the case of deallocation, can relieve you of that burden by saying, all right, when I know we're finished with this memory, it can be deallocated. With concurrency, same thing, but worse, right? If I talk to students about concurrency, it's how do we know what is shared memory in the program? Well, we have to look at it. We have to think about it carefully. We're going to look and see, all right, this data is passed between threads. This data is going to do this, and then it's finished. So then we can deallocate it once it's been moved to the other thread. But in the meantime, while it's in use, it's still shared. Okay, so we have to look for uses of shared memory, and then we have to apply appropriate synchronization constructs for them. So create a mutex, initialize it, lock the mutex before you access the data, unlock it when you're finished, and then verify that you didn't overlook something, right? Does the function have an early exit in the case of an error condition, in which case we might forget to unlock the mutex? All of these things, Rust forces you to think about them. If this data is shared, then it requires that you use some sort of concurrency construct around it, whether that's you put it in a mutex or you use an atomic reference counted type for passing it between threads. All of those things, the language is forcing you to think about those. And my feeling about this is that when you practice this sort of thing when writing Rust, it builds that muscle, that way of thinking in your brain, such that if you write in another language, you have a much easier time remembering, oh yeah, I have to care about what are all the possible accesses of this. Should I make a copy of this before sending it to another thread? And that way it reduces the potential for race conditions. Those kinds of things, it turns out, I think are very helpful in terms of learning a new language. And like I say, Rust is the example that I use because Rust sort of enforces this way of thinking. Not every language does that. You could equally argue that some other languages actually suggest bad habits about certain things. That if allocating memory is easy and deallocating is automatic with garbage collection, it to a certain extent incentivizes you to not care about how long memory should live because it's the job of the garbage collector to figure it out. That's not always going to work out. Sometimes you'll end up with elements in a collection that really we don't need anymore, but we've left them in there. You could think of that as data hoarding to some degree. That's not ideal, and languages can't necessarily prevent that, but certainly learning a new language can be a way to think of problems in a different way. I talked about Rust. Rust is also good about encouraging immutability. If you really want to go down that track, learning a functional programming language, and I mean a functional programming language, not a procedural programming language like C, is even better in this regard because it forces you to think about things like side effects of functions and discourages global state and other fun principles. So those are the reasons why I would say learning a new language is worthwhile. I just want to end with a little note about actually doing it. And my suggestion when it comes to actually doing it is that reading about it really isn't enough. If you want to become proficient with the language, if you want to feel comfortable using it for something, if you want the information to just stay in your brain. You have to use it to write something. And you can start with something very easy. Go to one of the learn a language websites. Do some exercises. And in the beginning, it makes sense. Okay, given the following resistor colors, what is the resistance of the corresponding resistor? You can solve those kinds of problems. They're good ways to sort of get warmed up with the language. But you'll only really get into it if you write like a little program that actually does something useful, right? That forces you to contend with some real-life scenarios. You will probably write some tests for it, maybe set up CI/CD, automatic tests when you commit to the repository in GitHub or some other code management tool. Those kinds of things are going to be necessary for it to really stick with you. So I would recommend, if you are going to learn the language, have a use case in mind for it, even if it's just something small for yourself or even something that you've already written in another language. It will be a much better experience if you actually give it a try and work in the language for real. And who knows, maybe it unlocks a nice new job opportunity for you, or one day you will be in a meeting and someone will be asking, does anybody know how to solve this problem? And you'll think, actually, yeah, I know how I'm going to do that. I'm going to do it with Rust. Okay, I will stop evangelizing Rust now.